Hi everyone, in this video we'll be talking about linear regression and how it works. First, let's think about a problem that we can solve using linear regression. Here we have house sizes and prices for each of these houses. So this is the house size on the x-axis and on the y-axis is the price. So if you look carefully, a square feet, if it's a house is 1,000 square feet, it's about $250,000. So the price is in thousands of dollars. And the larger it goes, the larger the house price gets. So right now in our data, we have some maximum of 700,000. So let's say you're a agent and you're trying to sell a house to someone, and you want to know how much a house will sell, for if its size is 1,700 square feet, 1,700 square feet. So how do we do that? We can try to get a similar data point, right? But what if we don't have a data point? Because we have till 3,000 square feet. What if you have a house that's 4,000 square feet, right? So how we can do that is by trying to fit a line. So as you can see, using this line, now for 2,000 we can say that it's about 402, and for 1,700 we can say it's about 310, 320. So that's how linear regression works. You just try and fit a line through some data, and that's how you can predict some housing prices. Also, so now let's just take a look at some notation. So how do we define all of this? Well, first thing is the training set. What the training set is all the data you're using to train your model. So you are using all of that data to create your model, right? So yeah, so you use that data to create that model, and it's called training set. And in our case, we have size as one parameter and price as the other parameter. So size is the x value and price is the y value. And as you can see, we have this arrow which has m written on it, right? So what m is the number of training examples. So right now we have 3 examples, because size 1,220, 2,400, 3,600. Those are a few, these are the 3 examples. And how do we specify some example? We can specify some example by saying 1,220. So by saying 1,220, that's a training example. And how can we specify some how do we find some specific training example? So what I is just the index. So what position is that training example at? So in this case, what I can say is I want to find the example that has 2,000, 400. So I can just do x2, y2. That will give me 2,400. So these are just some, this is just some notation that we're going to use in the videos. Let's take a look at our model, and this is how we'll actually create our model. We'll have a training set that will feed into a learning algorithm, and think of this learning algorithm as just a function. So this function takes in an x value and gives a y value. Now you see this small caret sign above y. What that means is y hat. So this caret sign is called a hat, and what this means is predicted y. So as you saw, we had examples like 1,220. So in that case, 220 was the real y. But using our model, if we create a line, and we predict, let's say 250 is y hat. So y hat is just predicted y value. Now let's see the equation for a line. So the equation for a line is just f of x is equal to wx plus b. So w is the slope of the line and b is the slope intercept. So in machine learning, w is also called the weight and b is also called the bias. Okay, and we are just trying to find the optimal values for w and b to fit a line through data, and we're going to see how we can do that in the following videos. Also, before ending this video, I want to tell you that there are two types of linear regression: the single variable linear regression and multivariable linear regression. So those are the two types of linear regression, and that's how linear regression works and how we can use linear regression. In the next video, we'll be seeing how we can actually fit a line through some data and how we can calculate what the best line is. Thank you.